Okay, this is practice 8, number 2, even though it doesn't have a number, with the man and the pot of gold. All right, so let's take a look at what we have. Let's add in, oh, I have no pencil. All right, let's add in the earth here, earth. Okay, and let's look at some interactions. All right, so we have, let's see, let's do everyone's gravity first. Okay, so what you're going to need to start doing is thinking of if there's some kind of a rope or attachment, just think of the rope as being part of the pot of gold, right? Don't think of it as a separate thing because then we'd have to make 3 force diagrams. So just assume the rope is part of the pot, okay? So that means the man and the pot are connected with a tension because he's pulling it, all right? And then he'll get a normal force from the ground and so will the pot of gold. And then since they're moving, okay, at a constant speed, they are also going to get a friction. Okay, so if they're moving or trying to move, remember they get a friction. Okay, so let's do the man. Oh, no, let's do the pot and the man, all right? So I didn't tell you this in class, I forgot, but do you see how this side is the pot and this side is the man? It's always easier if you put them in the same order as they look in the picture, all right? So that makes everything just flow a lot better, okay? So do that. All right, so let's start with, it doesn't matter, let's just start with the pot, okay? So he's gonna have a force of gravity down, so that's Fg, pot, earth, all right? And up is gonna be force of the normal on the pot from the ground, okay? And then the pot is feeling a pull from the man. Which way is it feeling it? Okay, the pot feels the pull this way. So Ft, pot, man. Okay, because he's feeling pulled to the right. And since he's moving at a constant speed, we know the forces have to be balanced, as all of them are in this unit. Okay, so that means I'm going to have something over here, which is force of friction on the pot from the ground, okay? Because the friction is always dealt by the ground, all right? Okay, so let's look now at the man. I'm gonna change colors. Okay, and the man is gonna be over here, and I'm gonna put him to the right because that's how he looks in the picture. Okay, so let's give him a force of gravity on the man from the earth, all right? And then up, he feels a force from the floor, force of the normal, man from the ground, or I'll call it ground. Okay, now the man feels what from the pot, not what he's doing, what he's feeling. Okay, so if he's trying to pull the pot to the right, but he's going to feel that as pulling him to the left. Okay, and that's the most confusing part right there, okay, is getting that to face the right way. So force of tension on the man from the pot, it's not what he's doing, it's what he's feeling. Okay, and he feels pulled to the left. Our left when we look, okay? And since he's moving at a constant speed, we know the forces have to be balanced, so this is gonna have to be the friction on the floor from the man, or sorry, on the man from the ground, okay? Right, so look, what he's doing, right, as he's pushing his feet, he's pushing backwards on those like little bristles, right, like from the activity. So the bristles are sort of getting pushed this way from his feet. So what happens is they are trying to bounce back this way, so it's pushing him that way, the friction. All right? Okay, so let's add some numbers in. A man of 80 kilograms, all right? So now you have to know when it's the mass, I have to use force of gravity equals mg. Okay, force of gravity is 80 kilograms, that's the mass, and little g is 10 newtons per kilogram. That's what we figured out in the lab. Okay, so that's going to make 800 newtons is going to be his weight. Okay, so whenever you see kilograms, you have to do this. All right, so let's look. This is the man's picture. So this is going to be 800 newtons. That's his weight, his force of gravity. Okay, he's pulling a pot of gold with 120 newtons. Okay, so he is pulling, that means he's the dealer. So that technically is going to be this one because he's the dealer. He's pulling, he's doing the pulling. All right, the pot of gold weighs 500 newtons. Okay, so since this is already in newtons, I don't have to do anything to it because it's already the weight. So that's going to be 500. Okay, and that's all we know. So let's see what we can do for balancing because constant speed, Up and down has to be balanced, okay? Up and down's not even moving. So if the force of gravity here down is 500, that means that this up from the ground is going to also have to be 500. Okay? And if the pot is being pulled to the right by the man, that means the friction is going to have to pull to the left, also 120 newtons, so that those are balanced. Okay? If we look at the man's picture, down, we see 800 newtons. So up, there's only one force, so it has to take the whole 800. All right, and then we're kind of stuck, so we need to start looking for the pair. So PM are our objects. So here's PM, here's MP, okay? And they're opposite directions, so this is going to be your pair. Okay, the pot is pulled to the right, the man is pulled to the left. So that's also going to be 120 newtons. Okay, and since everything's balanced, this friction also is going to have to be 120 newtons. All right, that is that.